Hello everyone, this is Aishwarya R. Today my topic is data mining and data warehousing. Now let us see what are the topics I will be discussing. First one, introduction to data mining and data warehousing. Second one, multi-dimensional model. Third one, difference between online analytical processing and online transaction processing. Introduction to data mining and data warehousing. Introduction. Now let us see what is data mining. Data mining is defined as a process used to extract a usable data from a large set of any raw data. Data mining, it is a process of extracting and discovering the patterns in a large data sets involving a methods at the intersection of machine learning, statistics and database system. Data mining refers to extracting or mining the knowledge from the large amount of data. Data mining has an application in multiple fields like science and research. It implies analyzing the data patterns in large batches of data using a one or more software. Data mining is also known as knowledge discovery in data. What is data warehousing? Data warehouse is a repository of information collected from multiple sources, stored under a unified schema, and which usually resides at a single site. Data warehouse is a subject-oriented, integrated, time-variant and non-volatile collection of data in support of management's decision-making process. The four important key features of data warehouse are subject-oriented, integrated, time-variant and non-volatile. Subject-oriented, it is organized around the major subjects such as customer, products and sales. It focuses on the modeling and analysis of data for decision makers, not only on the daily operations or the transaction processing of the organization. Integrated, constructed by the integrated multiple heterogeneous data source such as a relational database, flat files, online transaction records. Time variant. The time horizon for the data warehouse is significantly longer than that of the operational system. Non-volatile. A physical separate store of data transferred from the operational environment. Operational update of data does not occur in the data warehouse environment. Does not require any transaction processing, recovery and concurrency control mechanism. Three-tier data warehouse architecture. It consisting of bottom tier, middle tier and top tier. Data warehouse oftenly adopt a three-tier architecture as shown in the figure. Bottom tier it is a data warehouse server that it is always a relational database system. Backend tools and utilities are used to feed the data into the bottom tier from the operational database or from the external source. These tools and utilities perform the data extraction, cleaning and transformation. These data are extracted by the underlying DBMS and allows the client programs to generate the SQL code to be executed at a server. Example, gateways includes an open database connection and an object linking and embedding database by Microsoft and Java database connection. This tier also contains a metadata which stores the information about the data warehouse and its contents. Middle tier. It is an OLAP server that it is typically information either from the relational OLAP or the multidimensional OLAP. Relational OLAP, it is an extended of the relational DBMS that maps an operations on multidimensional data and the standard relational operations. Multidimensional OLAP, it is a special purpose server that directly implements a multidimensional data and operation. Top tier. It is a front-end tool where a client layer which contains a query and reporting tools, analyzing the tools or the data mining tools. Multidimensional model. Let us see what is multidimensional model. Multidimensional model is a data model used in data warehousing to organize the data into a structure that can be easily analyzed and queried. The model is based on the concept of dimensions, which are the different attributes or the characteristics that describe a particular object or an event. In a multidimensional model, data is organized into a set of tables, which each table representing a specific dimension or a set of dimensions. These tables are linked together in a structure called as a cube. Each cell of the cube representing a unique combination of values from the different dimensions. Multidimensional model is designed to make it easy to analyze a large amount of data quickly and efficiently. It allows the user to slice and dice the data in a variety of ways and to view it from a different perspectives. The multidimensional model provides several benefits over the traditional relational database models, such as efficient querying and analysis, data aggregation, data visualization. Efficient querying and analysis, the data can be analyzed by one or more dimensions. Data aggregation. The model allows the data to be aggregated across the multiple dimensions to make it easier to understand the trends and the patterns in data. Data visualization. The model supports the creation of the graphical representation of data such as the charts and the graphs which help the user to understand the data better. Overall, the multidimensional model is a powerful tool for analyzing and understanding the complex data sets, and it has become a cornerstone of the modern data warehouse and business intelligence solution. Example for multidimensional model. Let us take an example of a data of a factory which sells a products per quarter in Bangalore. The data it is represented in 3 dimensions. Here it is a data where the location is Bangalore. It can be any location like Kolkata, Delhi or Mumbai. And the type of items jam, bread, sugar and milk. Time quarters it is from Q1 to Q4. And here it is the cost which the different dimension of the items which are sorted according to the kind of items which has been sold. Here it is a 3D data representation where the time quarter is from Q1 to Q3 and the locations are Mumbai, Delhi and the Kolkata, and here is the cost where the organized into a quarters and the dimension of the data which are sorted according to the kind of item which has been sold. Here the facts are represented in rupees. So here it is a 3D representation of the factory which has been sold as per the quarter in Bangalore. OLAP and OLTP. What is OLAP and OLTP? First of all, we have to know that what is OLAP and OLTP. OLAP it is an online analytical processing. OLTP it is an online transaction processing. OLAP it is an online analytical processing is a category of a software tools and technology used for analyzing the data from the multiple perspectives, often from the data warehouse. OLAP it is an optimized for complex queries and data analysis, and it is commonly used in business intelligence and decision making process. OLTP it is an online transaction processing is a category of a software tools and technology used for managing the transaction oriented application such as e-commerce or banking system. OLTP it is optimized for handling the high volumes of transaction with low latency, typically supporting the thousands or the millions of transactions per second. Difference between OLAP and OLTP. OLTP it is an online transaction processing where it is an operational system. OLAP it is an online analytical processing where it is a data warehouse. Online transaction processing, it is a source of data where the operational data are there. In online transaction, it is a consideration of the data. The purpose of data to control and to run the fundamental business tasks in OLTP, to help with the planning, problem solving and decision support in OLAP. What the data reveals the snapshot on ongoing business process in OLTP. Whereas in OLAP it is a multidimensional views of various kinds of business activities. Inserts and updates. Short and very fast inserts and updates initialized by the end users in online transaction processing. Periodic long-run batch job refreshes the data in online analytical processing. Queries, it is relatively standardized and very simple queries in online transaction processing. Whereas in online analytical processing, it is an often complex queries involving the aggregation. The processing speed is very fast in online transaction processing, whereas in online analytical processing, it depends upon the amount of data involved. Space requirements can be relatively small in the online transaction processing, whereas in online analytical processing larger due to the existence of aggregation structure and history data. Database design, it is highly normalized with many tables in online transaction processing. In online analytical processing, it is typically denormalized with the fewer tables use of the star and the non-schemas. Backup and recovery. Backup and recovery, it is an operational data is critical to run the business. Data loss is likely to entail significant loss and legally in online transaction processing. Whereas in online analytical processing, it is instead of regular backups, some environment may consider the simply reloading the online transaction processing data as a recovery method. Thank you.